So one of the biggest issues that we face in Tennessee in terms of forage production is actually the tall fescue endophyte. It's something that affects basically every pasture across the state. In fact, every phone call that I get, every email I get, every question I get in some form or fashion is impacted by the endophyte and the impacts it has on both the plant as well as the animal. So I thought we'd spend a couple of minutes talking about that. So I want to start with a slide set here, and we'll kind of go through this. But as a little bit of information and background on tall fescue, so it's not native to the U.S. It's native basically to Europe. And if you go back in 1931, there was some tall fescue that was found on a hillside in Kentucky. The extension agent in the county saw it, didn't know what it was. The producer there didn't know what it was. They brought a professor in from the University of Kentucky. He identified it as tall fescue. You know, it was growing better than anything else in the area was. So he brought it back to the university. They did some research, and basically when you get into the early 1940s, the variety Kentucky 31 got released, and it basically revolutionized the forage industry in this Mid-South area. You know, it was very adapted. You could grow it almost anywhere, wet conditions, dry conditions, you know, anything. It would, it's very persistent. And so it just made a pretty big impact on forage production across this area. I have a book that's on my shelf over here that has this quote in it about tall fescue. It says a major difficulty is its apparent lack of palatability. Its agronomic characteristics are excellent, but is often rejected by livestock. And what they go on in this book to say is that you can compare tall fescue and orchard grass, and they can, you know, chemically be exactly the same. Same protein, same fiber levels, same energy levels, everything can be the same. But for some reason, cattle don't eat the tall fescue as well as they eat the orchard grass. And they didn't know exactly why that was, but they just knew that they saw that difference. So then if you go forward, you know, about, 30 to 40 years, we get into kind of probably the early 80s. What we found out is tall fescue has a fungus growing inside of it. We call it the endophyte. Okay, and it's not something that you can see from the outside of the plant. It doesn't show any sort of symptoms. You can't see any leaf lesions, leaf stripes, leaf spots, nothing like that. The only way you can see it is under the microscope. You can see here that we have, you know, the leaf cells, okay, of the tall fescue, and then in between the cells you have these fungal hyphae growing, okay? And so this endophyte, this fungus growing inside the leaves, is producing some chemicals, some alkaloids that cause some animal issues. So here's 3 different studies, and just to summarize these on all 3 of these studies. They put steers on tall fescue E- in the green, meaning the endophyte's not present. It doesn't have the endophyte. These steers gain basically 2 pounds a day. But then you put steers on tall fescue that does have the endophyte, the E+ in the red, and you can see it drops their weight gain to about 1 pound a day. So it's a significant impact on the weight gain of cattle that are grazing on that. If you go through and you look at research since then it's been done, there's a lot of things that it has impact on physiologically. These alkaloids cause a constriction of blood vessels, meaning that the blood doesn't flow quite as well, you know, through the animal. So they end up having just a slightly elevated body temperature, just a degree or 2 above normal. It also causes animals to have a shaggy hair coat, particularly during that summertime. So a lot of animals will not lose their winter hair coat, and so have this patchy kind of look on their side. There's been work here at the University of Tennessee that has shown that in cows, egg quality is reduced. In bulls, the semen quality is reduced. So you're getting hit on the reproduction side of it. Your herd won't have as many calves, and then also the calves you do have won't grow quite as well and gain as much weight as they normally would. So it's an extremely significant issue. It's not unusual to go across the state and see animals, you know, that'll be in a pond or in the shade trying to cool off. And it's a lot of times, I mean, it is some because it's hot, but it's also this endophyte causes them to be more sensitive because they have that elevated body temperature. And so it's a big issue that everybody in the state and in the Mid-South faces. If you have Kentucky 31 tall fescue you have, this problem, because our work has shown, if you look back on it, that 90+% of our pastures are infected with this endophyte. Now, the thing to understand, excuse me, is how does this fungus spread? So it's not like, most fungal pathogens that, they produce spores and they blow in the wind or move with rain or something like that. This fungus has no sexual stage to it, so it does not produce any spores. The only way that it moves is through the seed. So what happens is, if I have a plant that is infected, in the spring when that plant produces a seed head, that fungus is going to grow up that stalk, get in that seed, and then when that seed, is harvested and planted, then I have a new infected plant. So there is no plant-to-plant movement. It's only through that seed. So I can take an infected and a non-infected plant, put them side by side. The fungus will never move. It only moves through seed. And so this explains why all our Kentucky 31 tall fescue has this fungus, because you have infected fescue, you harvested it. If it's harvested for seed and it's planted somewhere else, that fungus just continuously moves because through that seed. Now, one of the things that was found out very early on is that if you take infected seed, okay, and you store it for a year, the fungus dies. And so now when you plant that seed, you have a non-infected plant. And so that was the original kind of thought process about how this problem was going to get solved. It makes sense. If you have a fungus in a plant that causes the problem, plant, that same plant without the fungus, boom, problem, is eliminated. But one of the things that we found out is that fungus has, not only does it have an impact on the animals grazing it, it has an impact on the plant. Here you can see Kentucky 31 fescue side by side. The E- over on this side, meaning it doesn't have the endophyte in it, and you can see the stand is not very good, it's not growing very well. Whereas over on this side over here, you have Kentucky 31 plus with the endophyte, got a good stand, green, lush. And so what we found out is the presence of the endophyte also impacts the plant by improving the drought, insect, and disease resistance. So you have a situation where if you have the fungus present in the tall fescue, the animals don't gain as well, cows don't rebreed as well, but the plants are very persistent, very productive. If you have a field that does not have the endophyte, the animals do fantastic, but it doesn't last very long. It's only going, that stand's only going to last, 2, 3, 4 years until either a drought or overgrazing or something ends up killing it. And so it's something that, most producers across the Mid-South region have chosen infected fescue because of that persistence. So what we need to think about is there's a couple of things to think about. One of them is, how can we reduce the toxicosis? Can we take advantage of the persistence of Kentucky 31, but minimize the toxicosis? And so what we've seen is one way is by planting clovers. So here's just a study done several years ago where they put steers on infected fescue, they gained 1 pound a day. They put steers on infected fescue with white clover, they gained 1.5 pounds. Now, if you remember back to that previous data that I showed, if there would have been a non-infected treatment in here, those animals probably would have gained 2 pounds a day. So I don't want you to think that planting clover eliminates the endophyte issue. It doesn't. It just reduces it, hopefully to the point where you can, kind of tolerate the impact of it. So that's one thing that we recommend, is make sure you plant clovers. Anywhere you have Kentucky 31 fescue, whether it be a hay field or a pasture, you need to make sure that you put clovers in there. We usually recommend 2 pounds of white clover and 4 pounds of red per acre. So that's one thing. A second thing is that you can do something to kind of minimize the presence of seed heads. So just here's some work that shows where the alkaloid presence is in the plant. So here they're looking specifically at an alkaloid called ergovaline, and you can see the red line here is in the seed head. The light green line right here is what we call the pseudostem, which is in the stem, kind of the base of the plant, and then the green is in the leaves. And what you notice is the seed head is where the highest level is. The next level is in this pseudostem in the base of the plant, and then the leaves have the lowest level. Now there's still alkaloids in the leaves. It's just not as high as what it is in the seed head and that pseudostem. So what that ends up meaning is we can manage these seed heads really and help reduce the amount of the alkaloids. So we can, maybe do something like rotational grazing. Okay, so if I rotationally graze, that can help me try to manage this. So for instance, if I come through in the spring, okay, I clip seed heads in May. So I'm getting rid of that top part of that canopy where there's a really high level of those alkaloids. And then through my grazing management, if I make sure that I keep at least 3 inches of stubble, don't ever graze down below 3 inches, because below that is where that highest level of alkaloids is. Then what I've done is I've gotten rid of the high part up top. I've also keeping them from grazing the high part of alkaloids down in the bottom. I'm staying in that range where my alkaloid level is not quite as high. Again, it's not going to eliminate the fescue issue, but it is going to help, kind of minimize some of the impact of that. Okay, so that's 2 things to do if you want to try to, stay with Kentucky 31, but reduce the endophyte impact. Plant clovers and clip seed heads and use good grazing management. There are some ways that you can totally eliminate fescue toxicosis. One way you can do is you can actually plant endophyte free. We know if you do that, you kill all the Kentucky 31 that's out there, plant endophyte free, then the animals will not have any more problems. The issue with this is the short stand life. So you better plant on every 3 to 5 years, you're going to have to replant. This is really not that attractive of an option for most producers in our region. But we do have another option. We can use what we call these novel endophyte infected tall fescues, or the non-toxic endophytes. And so here was a thought. There's some companies that went through and they said, okay, we know if tall fescue is going to survive in the southeast, it has to have the endophyte in it to be able to survive the summers. So what if we find an endophyte that produces all the chemicals that you need to have, the persistence without the chemicals that cause the animal problems? And so they basically started searching around the world trying to find endophytes that had the right chemical profile. And so they found some. And so what they did, basically, you take an endophyte-free plant, you insert this novel endophyte, this non-toxic endophyte in it, and then when you start harvesting seed, you have a non-toxic or a novel endophyte variety. And so the research has shown that, yeah, it works. One of the first ones that was developed was Max Q. And so they put this endophyte into a variety called Jessup. So here you have Jessup with steers grazing Jessup endophyte free, a little bit over 2 pounds a day. When they grazed Jessup with the toxic endophyte, they gained about 3/4 of a pound a day. Jessup with the Max Q gained about 1.75 pounds. Statistically, there is no difference between the Jessup endophyte free and this Jessup Max Q. So basically, they gained the same. So the data shows that the technology works, and that these novel endophyte varieties do have a place to be able to use, that they can be used on the farm. Now, there's been, some work that has shown that actually you don't have to renovate every pasture on the farm to the novel endophytes to get benefit of them. There's been some work in Arkansas that shows basically if you just renovate about 25% of your acres, and so take 25% of your fescue acres and put those into the novel endophyte, you'll get a lot of the weight gain benefits and everything, and particularly the rebreeding benefits that you would if you went to 100% of the novel endophyte. So, the big thing is making sure you understand the problem, and that if you have Kentucky 31 tall fescue, you have this, this issue with the endophyte, and so have a plan to deal with it. You may decide, hey, I just want to plant clovers and use good grazing management. Okay, you can. You're still going to be losing some, not maybe capturing all the weight gain that you possibly could, but you will help reduce the problem. Or you might decide you want to start moving toward the novel endophyte tall fescues. And if you do, that helps you eliminate some issues. So hopefully this has provided some information to at least get you started down the path of making the decisions on this.